Welcome to Emilat's math class, and today in this tutorial we'll be looking at the laws of indices. Okay, and in this tutorial you will learn how to use the basic laws of indices to solve indices problem. Okay, all right, and it's very important for us to ensure that, to let you know that every laws here is applicable in any given exponential or indicial equations. All right, okay, let's begin. Let's start with the multiplication law, or the multiplication rule. All right, now the multiplication rules tells us that if you have a raised to the power of x now times a raised to the power of y, what here you have that a raised to the power of x plus y, in which the two power here are being summed up. So here you have, as long as you have the same base, so the power is being what? Summed up. All right, for instance, let us say a raised to the power of 2 times a raised to the power of what? 3. Now, since you have the same base, you have what? A raised to the power of 2 plus 3, which will give us what? A raised to the power of what? 5. All right, for more simplified explanation, now in an expanded form, a raised to the power of 2 means a times a. Now times, now a raised to the power of 3 means a times a times a. Now since here we have the same base all through, you can just take a, then how many a's are we having? 1, 2, 3, 4, and 5. Okay, so this is the first law, and here is how to apply it. Now the second one, we're talking about the division law, or the division rule. Now let's say, for example, that a raised to the power of x now divided by a raised to the power of y. Now in this case, what we just need to do here, as long as the base are the same, here you have that a and the power here will be subtracted from each other, so we have x minus what? Y. Okay, now in its application, this is something as saying a raised to the power of what? 3, then minus, divided by a raised to the power of 2, which will give us what? A raised to the power of 3 minus what? 2 equals what? A raised to the power of what? 1. Okay, you can also have it a raised to the power of 2 divided by a raised to the power of what? 3. This will give us what? A raised to the power of what? 2 minus 3, which will give us a raised to the power of what? Minus 1. This is actually another law in indices, but let me wait here, or let me pause here until when we get to that side. Okay, so this is actually the application of the division rule or division law in indices. Okay, now let's move to the next one, which we'll call the root or the fractional indices. So here we have 3. Now the fractional or the root law rule rather. So in this case now, let's see a raised to the power of 1 over m. Now this is the fraction in this indices. So here we have a raised to the power of 1 is actually the mth root of a. And that's why it's called the root law. Now we can also have that a raised to the power of n over m. Now this one is, since you have your denominator as m, you have that this is the mth root of a, all raised to the power of what? N. Okay, so for instance, we can have that 27 raised to the power of 1 over 3. Now this means, following this law, it means that the cube root of 27, right? And the cube root of 27 is 3. Final answer. Now another law here we can say, let us say 16 raised to the power of 1 over 2. Now 1 over 2 here is actually the square root of what? 16, which is what? 4. Okay. Now let us use this law. So here we have let us say 16 raised to the power of 3 over 2. Now this implies the square root of 16 all raised to the power of what? 3. Now the square root of 16 is what? 4. Now raised to the power of what? 3. Okay, and if we tend to expand, that is 16, 4 times 4 times 4, which is what? 16 times 4, that will give us what? 64. Okay, alright. So let us move to the next one, which is number 4. So on number 4, we're talking about the power rule. The power rule. And in this case here, let us say here you have that a raised to the power of m all raised to the power of what? N. Okay? In this rule, what it implies that this power will be multiplied. So here you have that a will now be m times n, that will definitely give us a raised to the power of what? M n. Now how do we apply this? So if we have that 2 raised to the power of let's say 3 all raised to the power of 2. Now following this law, it means 2 raised to the power of 3 times what? 2, which will give us 2 raised to the power of what? 6. Okay, we can actually still move further in simplifying this further. This implies, okay, let me use here, this implies expanding this 2 raised to the power 3, it's 2 raised to the power 3 gives you 2 times 2 times 2. Now, which also means 2 raised to the power what? All this raised to the power of 2. And when you want to expand this one again, the same thing as saying 2 times 2 times 2 times 2 times 2 times 2. Okay? Now, our final answer will then be, since they all have the same base, how many? 1, 2, 3, 4, 5, 6. So here you have what? 2 raised to the power what? 6. Final answer, which correspond to this. Alright, so the next one we'll be talking about now, number 5, is the negative index. The negative index. Now, and this is where this comes to play. For example, you have a raised to the power of minus 1. Okay, a raised to the power of minus 1 actually tells you this is the reciprocal of this raised to the power of the power. Now, this implies that the reciprocal of a raised to the power of the positive index. Okay, which also you can still say that a raised to the power of minus 3, it means the reciprocal of a raised to the power of the positive index. Okay, now these are the laws. We can actually still prove this. We can still prove this. For instance, if you have that a 0 divided by a raised to the power, let me say this 3. Now this implies our a here, okay, anything raised to the power of 0 is actually 1. I guess we've not done that yet, so that will be 1. Now divided by a raised to the power 3, which also implies that 1 over a raised to the power 3. Okay, so in this case also, following the law of division here, we can say this is a raised to the power of 0 minus 3, which is the same thing as saying a raised to the power of what? Minus 3, that is 0 minus 3. So if this equals to this and this equals to this, automatically we can now say that a minus 3 equals 1 over a raised to the power what? 3. Alright, so these are the laws. Okay, for the sixth one, which is the zero law, that says a raised to the power of 0 equals 1. By proving that, we can say, now following the division law here, we can say a raised to the power of, let me see, 3, now divided by a raised to the power of 3. This same thing as saying a raised to the power of 3 minus 3, which will give us a raised to the power of what? 0. In also this case, we can say this is a raised to the power of 3 over a raised to the power of 3, which is, when you cancel out, equals to what? 1. So if this equals to this and this equals to this, so we can therefore say that a raised to the power of 0 equals what? 1. Alright, now these are the laws of indices, and this laws is applicable to any form of indices. Yeah. So if you love what I've just done, ensure you click onto the please subscribe to my YouTube channel, and ensure you click on the notification button to be notified of all my videos in basic mathematics. Thank you, and God bless you.